robot has been rude, apparently. We got rid of it. So now I'm looking very much forward to the next subject, because many people don't know how important it is what we're going to be talking about in the next presentation, because when it's about efficiency in production, above all costs too, there's one thing that is really crucial, and that is lubricant solutions. Now, if you look at this, there are subjects such as automation, possible savings, which can be supported with intelligent systems. How that's done is going to be presented to us by someone who knows much more about it than me. I'm sure about that. So welcome on stage, Christoph Osterloh from Castrol, Germany. Christoph, the stage is yours. Thank you, Sven. Today I'd like to talk about automation of lubricants, because lubricants in particular have been coming more into the focus of intelligent automation, and for water mixable cooling lubricants, a subcategory of cooling lubricants, there's a strong trend toward more automation. And here we see that companies of different sizes and different industries are starting to completely automatically manage their water mixable cooling lubricants. What was the case in the past, and how do many companies still do it? Well, management of cooling lubricants is still done completely manually, and I'm sure you're familiar with this. It all begins with regular measurements. This is done in Germany once a week. A person goes to the coolant tank, an employee takes a sample, calibrates the refractometer, has a look into it, and tries to read the value, and then tries to find the R value specific for that lubricant, and then he multiplies it, and then he puts it into a table or on paper, sometimes Excel spreadsheet, rarely in databases. So as you can see, there are a lot of areas there where things can happen. You miscalculate, you read it wrong, you calibrate wrong, and that's really not the ideal solution. And then at the end of the day, you've got reactive management. So you've done your measurement, you've documented, and now you've got to refill your tank. And this too is done kind of in a more or less way. If your measured value is not 100% correct, and then you start estimating how much could fit into the tank and how much you've got to add, then at the end of that whole thing, you are very imprecise, and you can get varying results. And we put all of this on this chart here. This is the variation of conditions for coolants in production. Now, the cooling lubricant is rarely within the ideal area, which is between the two yellow lines, and it's rarely there. Sometimes you have excess concentration that's above the first yellow line, and that, of course, leads to higher costs on the one hand, because you've got more consumption of oil. On the other hand, you've got negative effects on your production, for instance, foaming. And in extreme cases, you can even have health risks for your employees, for instance, skin irritation. But on the other hand, if your concentration is too low, that is, your cooling lubricant proportion in your emulsion baths is too low, then you have other negative effects. You have growth of bacteria, which is fostered, your tools suffer, your baths don't last as long, and if you fill in too quickly, you can have temperature shocks on the parts, you're producing geometry changes, and you have a problem sticking to your specifications. What's the picture? What's the chart we'd prefer to see? Something like this. Here you see the cooling lubricant, which is always kept within the ideal parameters. And this means this. You can only achieve it by constant measuring and very precise measuring, and constantly comparing target to actual, and then refilling exactly when needed. And it's best to do this several times each day, small doses. Manually, it's almost impossible to do this. As we know, there's a lack of precision here, and also there's not enough time to do that several times a day. So curves like this, which give us the highest cost efficiency and highest precision in production, can only be achieved by automation of measurement and refilling. But it's not only the case with individual machine tools that automation is important, it's important for the entire company. A lot of companies in Europe, factories in Europe, have a hard time finding skilled employees for lubricants. And there's cost pressure, and there's more cost pressure, more documentation required. And all of these challenges can be met by automating the management of lubricants. So what does this mean specifically? Well, just imagine a project where you could have automation of the water mixable cooling solutions in your company and what you could save. One of our customers actually did this. The customer has 10 machine tools with a filling volume of about 1.5 cubic meters per machine, and they put on automatic measuring technology and automatic refilling technology, and for 1 year they did a comparison between completely manual management of the machines and automatic management, and the result is more than 72,000 euros were saved. And the savings can be broken down into three main categories. First of all, the cooling lubricant consumption was down by more than 30%. It's not so good for us, of course, but we have to accept it. Now, this meant that there was less over-concentration, excess concentration, less in the yellow and red areas. In addition to that, the bath times were lower. They didn't go into sub-concentration, too low concentration, so the baths lasted longer, less bacteria grew, and there was less waste. And at the end of the day, the customer was able to work much more precisely than in the past. Previously, manually, they said to the people, okay, 8-9% concentration in the tank. That's the goal. But with automatic refilling and constant monitoring, he was able to reduce that to 7%. So he could go down much lower, and nevertheless, he still had perfect performance. Another big cost area, that's operating costs. The customer reduced that by about 60%. That is 60% less manual effort. If you look at your company and figure out how much time it takes to walk over to the machine, take out your refractometer, take out a sample, calibrate it, read it, document it, and then refill manually, well, per machine, that's 20-30 minutes per week just for doing that, for one machine. Now, think of what that means for the entire year for all the machinery. That's a lot. And, of course, that wouldn't mean that the people don't have anything to do. They can do something else that creates value. And the last point, and it's perhaps one of the biggest ones, is the wear on your tools. Our customer said that the tools lasted about 7% longer. And as you all know, machine tools cost a lot of money, so that's a huge amount of money. And because we ensure there's always enough lubrication, the tools last much longer, and the lubrication in the machine can be based on the requirements of the actual tool being used. Now, we've got to add, there's no rule of thumb for all of the savings. You've got to calculate it individually per company. Every company will have different results. But for that, you really don't need a major project either. Often we're asked by our customers that have this on their agenda, this subject, well, do we have to have a huge project? Do we have to get approval from our board of management? Do we have to remodel our entire production facility, put in new piping and so on, or can we keep it lean? And we can say yes. The first steps in automation don't have to be a huge project always. It can be done in a very small level, small scale, and just measure the advantages there, and then make it tangible for the entire company. And it's easy to do with some relatively small steps. Think about it like this: you want to do automation of cooling lubricants in your company. Well, first of all, you analyze your factories, and the first step is quite easy. Ask yourself this: what machines cause the most problems? Where do you most often have to intervene manually? Where do you have to most frequently refill? Or what machines are so far away, for instance, they're in a different building somewhere, that I don't want to have to always walk over there? And then As soon as you've figured out which machines these are, where you have the potential for automation, then you can take the next step. Look for a partner. Find a partner. Don't try to do it yourself. That doesn't usually make sense. For instance, ask your lubricant supplier. Many lubricant suppliers have a lot of experience in automation. They've supported projects. They've done projects for customers. And also ask partner companies in your region or other factories in your group. Sometimes initial attempts, initial projects have been tackled about how to automate coolant management, and you can learn from the best practices of others. And then if you have a machine or one area in production that you've selected that you'd like to do automation, where you'd like to do automation, and you have the right partner, well, then the next step is proof of feasibility. And that's relatively simple too. Begin on a small level. There's devices you can rent, and they don't have to have invasive installation in production. You don't have to install new piping. You don't have to convert machinery. You don't have to shift your machines around. It's possible without all of this, with mobile test devices, to check how automation in production could be done. And then what you have to do is just learn from all of this. It's really not just about the money you can save, it's about building trust and making sure this is secure and safe. You can trust the system to ensure that your machinery won't dry up. That's what's shown here. And you can produce just as reliably as if you have someone who's looking into there on a regular basis, a person. And learning about these new technologies and processes, that's a long process itself. And you don't want to ask too much of your production people because it's brand new. For years it was done differently, and now it's going to be done completely automated, and this is a challenge. But when you've automated your first machines and you see the initial success there, and maybe you've discovered new challenges, well, in that case, you can then go on and transfer that to the rest of your production facility, and your decisions will be much more well-founded. Does it really make a lot of sense, what I've been thinking about here, or should I actually do something else? And these learning cases are very important to gain trust and also establish a foundation in a company for taking the next steps in automation. Okay, well, that was it for me on automation. So if you are thinking about doing this, come and see us at our booth in Hall 11, and we can talk about current projects and ideas on automation of cooling lubricants. Thank you. Thank you. I'm surprising you coming from the back there. Oh, we do have some questions. Oh, no, those are the questions from the previous one. So I do have a question, a couple questions, Christoph. Now, if we look at your solutions, we're talking to a certain extent about predictive maintenance. Is that true? Yes, yes. But we actually talk about proactive maintenance. We don't predict the condition of the lubricant. We react proactively to the current conditions and then keep the coolant within the legal parameters. How do you get those parameters? Because I had a look at the chart there where you showed the different parameters that could be crucial. So how does the system get the parameters? Well, we've got very innovative measurement technology that's incorporated in our system. So many times per hour, or even more often than that, it does its measurements, and then it picks up the parameters there, records them, and then it compares them to the target values that you've entered previously, and it actively then makes changes. So if the actual parameters are different from the target ones, it proactively makes a change. For instance, it adds lubricant, it adds additive, or it can add just water too, so that it remains within the necessary parameters. So you were saying you should begin with one machine and test it. Now, is it true that manual intervention is necessary, or manual checking is necessary to make it certain? Or do you say, if it's installed, it's fully automatic, you don't need to worry about it? Well, I'd begin slowly. I'd say, check it manually first to make sure that you're certain. For the first 1-2 weeks, you can always do that to get the feeling, okay, is that running well? Can I trust the system? And then that'll happen less and less automatically. And we have customers who haven't really done anything at all for months, haven't intervened for months. They're certain about it. They know how it works. They know that it does work. They know the dashboard and the help it provides. So they basically do almost no manual intervention. Okay, let's talk about the predictive subject, if I may. So theoretically, if I generate all the data or the measurement system picks up all that data, after a certain amount of time, the machine knows 100% how much that machine will consume. Now, on the basis of that, can you gain insight into how much you have to order and keep in stock and so on and so forth? Is that true? Yes, yes. So your ordering can be done completely automatically too, and you can estimate on the basis of your consumption when you'll have to order new lubricant, and then you can automate that with us too. So that means you don't have to worry about your machines running dry or not having enough in stock. Well, are you already connected to the system? Because that's a vision for the future. I don't have to call you. The ordering will be done on the basis of the knowledge that the machine garners. That's something that's planned. Well, we do have that already. We've got automatic tank telemetry, as we call it. So we have a look at the fill levels of the coolant tanks. Then we predict when they probably will be empty, and we can send out deliveries early so that our customers don't have to worry about it and do it. So they always at least have the amount in stock that will allow them to continue to manufacture with no problems. I'm not from that industry, so it's new for me. So let me ask you this. What percentage of the cost are we talking about? What are we talking about here for lubricants? It's an elementary part of the process. It won't work without it. But how important is it in the overall context, the subject of lubricants? Well, it depends on what you do, what your manufacturing is. Let's say you work in chipping. It's about 2% that goes into lubricants. Now, at first glance, 2% doesn't sound like a lot, but there's huge potential for optimization there, because if you improve that, it'll have an impact on the other costs, for instance, tool costs or the quality of the parts you produce. So the 2% there is small, but it has implications for all of your manufacturing facility. And so optimizing the cost there is really important. But 2%, that's just the material, the lubricant. You don't have to do the checking. You don't have to check it regularly, manually, and so on. That's probably a big savings factor too. Yes, there are many other operating costs that are lower too. The 2%, that really it just is the beginning of making your entire facility more efficiently. Do you have a solution at your booth here? Yes, we've got a model at our booth, and we can present it to you if you come by. Two of our customers have said that we could look into their production facility, so we can go live in there and look at their production parameters and have a look at how two of our customers are manufacturing right now live. Well, great. Thank you, Christoph. Let's give you a big hand. Go see that booth. It really is worthwhile. Thank you for that presentation. Thanks.